Okay, here we go, 8th graders. We are doing our first YouTube video, and I'm just going to get us set up for Newton's 3 laws. We'll be doing more videos throughout the week. Hopefully I can get outside and do a couple of interactions with actual motion and show you guys some Newton's laws. But for this video, I promise to keep them all short. So hopefully in 4 minutes or 5 minutes I can cover Newton's 3 laws and just give you the basics. So, Newton's first law, commonly called law of inertia, basically states that once an object starts moving, it's going to keep moving, or once an object stops moving, it'll stay stopped moving unless an outside force, a push or a pull, is applied to it. So if a big object starts moving, a bigger pull or a bigger push will have to occur to make it stop moving. If an object's not moving at all, a large push or a large pull on a big object, or a small push or a small pull on a small object will cause it to move. The key to this is understanding that inertia is directly related to mass. The amount of mass an object has will determine how much inertia it has. And again, inertia is not a force. Inertia is just the object's tendency to not want to change its motion. Newton's second law, commonly called F equals ma, but in reality, force equals mass to acceleration is not what Newton said. Newton said an acceleration of an object will depend on the net force acting on the object divided by the mass of the object. So if I take all the forces I apply it to, which is friction and pushing or pulling, gravity, the normal force, all the different forces acting on an object, the net force in one direction divided by the mass of the object will tell me how fast it will accelerate. Now oftentimes people want to say the force is dependent on the mass acceleration, which is true, but that's not really what we're going to work on. We're going to talk about how net forces and mass affect how fast something accelerates or decelerates, either way. Finally, the third one is opposite and equal reactions. This is the one everyone talks about. There's always an opposite and equal reaction to everything. I push the wall pushes me back. A lot of people think that's how motion, only reason motion occurs is my foot pushes back on the ground pushes back on me, causing me to move. But in reality, it's all three of Newton's laws coming together that cause motion. The opposite equal reaction one is very important, but you need inertia, different inertias, and you also need F equals ma or A equals F net over m to make it occur. So again, I'm going to go over the three laws more in depth throughout the week. I just wanted to quickly go over that the three laws are law of inertia, acceleration equals the net force divided by the mass of an object, and opposite and equal reaction laws. Remember, inertia is directly related to mass. The more mass, the more inertia. The less mass, the less inertia. And that just means an object's tendency or desire to remain in motion or remain still once it stops. And quickly my notes here. When I talk about net force, we're going to have a whole little lesson on this. But remember, net just means total. So if I push something, I'm applying a force to it. But there's also something pushing back, which is friction. Air resistance can lead to more friction. Gravity is pulling down on the box. Normal force pushing back up on the box. So net force means total force. Remember, mass is not the same as weight. We'll get into that more in the video. Hopefully you guys will come along with me this week, watch a bunch more videos, and we'll get Newton's laws in action. Have a great day.